All right, this is Unit 2, Lesson 8 of our calculus class. Unit 2 is called Derivatives. Lesson 8 is called Sum, Difference, Product, and Quotient Rules. So we're going to learn some rules around derivatives here. So a lot of these are basic properties of derivatives of functions, and we're going to learn how to differentiate using addition, subtraction, um, multiplication, and division of functions. Or you could say function composition kind of stuff. So a few basic derivative rules. First one, constant rule. If I take the derivative of a number, it's just going to be 0. The derivative is going to be 0 of any number. If you think of the graph of y equals any number, it's just going to be a horizontal line. And so any tangent line on a horizontal line will be 0. So that one kind of makes sense. The power rule, we've spent a couple lessons unpacking. Constant multiple rule. So if you take the derivative of a number times a function, you can really just put that number outside of the derivative and take the derivative of the function itself. The sum rule, if you're taking the derivative of two functions added together, you could take the derivative of each function separately and slap it a plus sign or a minus sign between them. It's difference rule. And this is consistent with the practice we've been doing with deriving polynomial functions. Okay, so here's the two function rules we're going to unpack in this lesson and spend the most of our time on. It's the meat and potatoes, the product rule and the quotient rule. The product rule, if I have some function h of x and it is equal to two other functions multiplied together, or the product of h of x is the product of two other functions, then when I derive h of x, I can write it as the first function times the derivative of the second function plus the second function times the derivative of the first function, or f times g prime plus g times f prime. The quotient rule, so if h of x is equal to the quotient of two functions, so f of x over g of x, then this one's a little more complicated. We have g times f prime minus f times g prime divided by g squared. Not g prime, but g squared, so just the original function times itself. The way my calculus teacher taught me back in the day was if you think of the top of the function as if the numerator is high and the denominator is low, then the rhyme goes, it's low d high minus high d low over low squared. Low d high minus high d low over low squared. If you can get that one down in your head, that's great. That'll make things a lot easier. Let's look at some examples here. So can you identify the two functions being multiplied together in each of these examples? Well, in the first one, we have a polynomial times a trig. The second one, we have a radical times a trig. So if I just quickly identify what's my f of x, what's my g of x, what's my f prime of x, what's my g prime of x, then I can plug those into our product rule. So remember, the product rule is the first function times the derivative of the second, plus the second function's derivative times the original function, or the original g. So f times g prime plus f prime times g. You kind of see some, you can almost call that cross multiplying going on there. So we get 3x squared plus 1 times cosine of x plus 6x times sine of x. And we could probably simplify this a little bit, but we're not going to, because like we've said before, this is calculus, not arithmetic, not algebra class. Same procedure for the second one. It's multiplying two functions. So identify f of x, identify g of x, find f prime and g prime, and plug in accordingly. F times g prime plus f prime times g. And notice I did f prime times g. The original function was g times f prime, but multiplication is commutative, so it doesn't really matter which order you write those in. Okay, two more, but using this time, we have, well, still product rule. The first one, we've got a power rule and we've got a trig function. And so we'll do product rule there. Second one, we have three functions in here. We have a function f of x plus a function g of x. is equal to x, and then times a function h of x. So to evaluate this, we're going to say, okay, so we're just going to split this up, the addition. We could take the derivative of the first thing and then take the derivative of the second thing. And the derivative of f of x is just going to be x, power rule. The second part, if we take the derivative of this, we have two functions being multiplied. So this is going to be the product rule again. So the identifier g, h, g prime, and h prime. And we'll do the derivative of that piece, which is, well, we can go, let's see here. What did I do? Oh, yeah, f times g, excuse me. I'm using g and h now. G times h prime plus g prime times h. And then we get this function right here. And we can simplify that a little bit. This is just plus cosine. We could maybe factor out an x here if we wanted to, but we're not going to. All right, so here are two examples using quotient rule. Remember, the rule is low d high minus high d low divided by low squared. So my high function is 2x squared plus 1. My low function is 5 minus x squared. So if I take the derivative of each of those, I get on top f prime would be 4x. Bottom g prime is negative 2x. So low d high would be right here, 5 minus x squared times 4x, minus high d low. So high is 2x squared plus 1. The derivative of the bottom is negative 2x. And then it's all over low squared. So low is 5 minus x squared. So we go 5 minus x squared, quantity squared. Second example, same procedure, but a little easier to work with, or a shorter polynomial. F would be x, so f prime would be 1. G would be x plus 1, so g prime would be 1 as well. And so we do high d low minus low d high over low squared. I think I just didn't finish this example in class. My bad. All right, so here's some basic derivative rules. Most importantly, the product rule and the quotient rule are probably the ones that take the most effort to think about, so we'll spend the most time practicing those in our homework.